So we may do requirement gathering, and when we want to properly implement a database. Then after, if you find some unseen relationships, we may come up with some associative intersection table. For an example, you may have two tables called authors and books, but you may not be able to store, because one author may have written many books, and the other thing, one author or the one book, a given book, can have many authors. Therefore, we have to go for another arrangement like this, which we call associative or intersection table in between books and authors. Okay. Otherwise, we would end up with many null values as well as the replicated data. Having this arrangement, we may save a lot of space, utilize the space in an efficient manner. Now we'll look at the relationships. So you may share many types of relationships, but they can be categorized as one-to-one, one-to-many, and many-to-many relationships. Have you represented these relationships in your ER diagrams in previous semesters? Have you identified these relationships? I hope you have done ER diagrams in previous 2 semesters. Then did you use any notation to show these relationships in your ER diagrams?
So we had relationships, but not use notations.
Have you heard about something called cardinality ratio?
Yes, sir.
Right. That is the thing we represent a relationship in ER diagrams. So how these relationships you identify? That is one important thing. Is it happen by default, or do we have any specific reasons to implement such what is called the type of relationships?
Yes, I depend on what we are drawing or designing.
No, actually, if you may draw, it's your drawing now, so you may draw it as one-to-one or one-to-many or many-to-many.
Yes, sir.
But how actually we verify whether our ER diagram is having the proper relationship? Is there any way of having that relationship correctly? Do you have any idea? Normally, it depends on the way we want to design our system, right? Now, let's take one example. In this particular lecture, there's only one teacher, but many students, right? So it is a requirement of the university. Normally, we are having one-to-many relationship we maintain because there are lack of resource person. It's one thing. So, but if you consider, so the same teaching can happen individually by one-to-one relationship, right? There, the teacher and all two entities, the teacher as well as the student, involves those two entities, but their cardinality ratio can be defined one-to-one in individual mode and one-to-many in which we require in schools or universities. Like, right? With that context, we have to define the cardinality ratio. So there are some places where by the nature it limits to a certain relationship, right? Uh, if you take one example, we may have one moon and one sun. By the nature, we cannot go beyond that. So if you want to create another relationship, it won't work then. Right? For the earth, we can have only one moon as well as one sun, but the sun can have many uh, planets, right? That is defined by the nature. So you cannot have one sun and one planet type of relationship, because by the nature it is defined. But the other things, normally when we learn about business rules in future, you may encounter, depending on different requirements, we have to model in such a manner, right? Therefore, the same entities may be having one-to-one relationship in one system and one-to-many relationship or many-to-many in another relational database. Right? Is it clear to you?
Yes, understood.
Right. But in normally exams and questions, you are giving some clues, then you can get the idea of having what type of relationships. But in real scenario, you have to identify by having interviews, discussions, then you may come up with the relationship type to be implemented. So in one to many relationships, I think you can just identify that. For each occurrence in a given entity, there can be many or more occurrences in the second entity. It's obvious, so one teacher can have many students. If you take individual classes, one teacher can have one student. Also, the reverse is also true. One student have one teacher. In many to many, you have many entities related to many other entities. Right? Therefore, it's a bit complex to handle this type of relationships. If you take this one-to-one type of relations, so you can refer one table from one table to the other, or from other table to the other table. So it can be very easily implemented. But in one-to-many, also the reverse is difficult. You can point out one and many part, but if many are related, since one is relating to many, so that direction is a bit complex. In database, we use several terminologies. So when you even write your answers, you can adhere to this terminology. And the other important thing, if you face for an interview, they would ask you some questions regarding the terminology used with databases. So in databases, we call populating a database. When we call populating, it's inserting data to your database tables. The querying can happen in many ways. So it is the basic way of interacting with your database. Right? You can query regarding combining several tables, and you can get some data, retrieve some data using queries. And you always talk with the database using queries. Therefore, we normally use standard query language called SQL. It is normally called as structured query language. But apart from that, Oracle uses something called PL SQL. It is run on their PL SQL engine. We will be actually getting some hands-on experience using some Oracle stuff. So we'll do it at the latter part of this lecture series. Then the other thing is manipulating a database. You should always query and update the database to understand or reflect your subset of the world, and you may need to generate some reports. If you take a banking system, you may get weekly reports, daily log sheets. There can be many things, transaction reports, and the balance sheets. All of those things are records which has to be generated through the system, and it uses data manipulation language as well. Then application programs, normally to access database, none of you is going to write a query. For an example, if you want to withdraw some money from your ATM, none of you is going to write a query and get the money from the bank, right? What you do is you insert the ATM card, then it prompts you to insert the PIN number. After authentication, it prompts you the services available for you. You just select the required services. When you do that, you interact with that application, it automatically generates the required queries and sent to the banking database, right? Even though the money is deposited in the ATM machine, your database has to verify the thing in order to get the money out of your ATM machine, right? If that part does not happen from the database side, you will not be able to withdraw money or even to check the balance of your account, right? All the account details are not within the ATM, it is in a database system. Then we call such a thing actually as a transaction. So transaction normally happens as an atomic unit of queries. Either it happens or it rolls back. So therefore, if a particular transaction fail at any single point, then all transaction reverts back to the state where no transaction happened. Okay. If you have any experience regarding that, then you can recall that memory when you try to withdraw money from an ATM and suddenly it would go off or go offline. But your transaction, you were in the middle of doing your transaction. Just before you withdraw the money, you could not complete the transaction. So it has to roll back into the state like you did not do any transaction at all. So when you call defining a database, you have to specify data types, structures, and constraints. That is why when you implement a database, there is something called metadata. I think you might have heard about metadata. These metadata describes about the available data actually. Now, if you think how many clients completed their transactions, right? It's some data regarding available data. Even if you want to check how many tables you have created, it can be found using metadata. The available capacity of the database, those everything can be considered as metadata, but in different contexts. When you want to get some information like that, you have to refer metadata. Databases, they have separate tables for you to refer when you want to get this type of metadata. As we have already discussed related to database implementation, this process can be in brief categorized into 4 different sections, or requirement specification and analysis, and conceptual design, logical design, and physical design. Your physical design would be the final database implementation. Therefore, it would be very important for you to understand this requirement collection. Now, as you are IT students, you would definitely have to complete your final year projects. Then you have to identify the requirement for your software as well as the requirements of your database. Right? Those two things has to be completely understood, because you cannot come up with a smart piece of software if your backend or the database is not going to work properly. Therefore, when you design your database, you should collect required information, and there are requirements related to database. They may not be having a clear idea about the database. They may explain you regarding the piece of software they want, but you have to somehow figure out what are the type of entities you have to store, what is the table structure. You have to come up with an ER diagram. Once analyzed, it is called the conceptual schema. So the description of database requirements has to be. Therefore, you have to clearly understand the database implementation process. Have you done any software development life cycles in previous semesters? Right. So I think you may be familiar with the very preliminary software development life cycle called classical waterfall model. Actually, it's a good place for you to understand all the activities which you have to follow during the software development. But in that case, it mainly focuses on software implementation. In the same way, you may have to get the database related requirements as well, because implementing a database is not that much easy, right? Because if you check the budget and the other relevant costs involved with the database, maintenance, and the staff to be maintained, right? It costs a lot if you consider a proper implementation of a database. I think you may have heard about database administrators. You can just think of how they are paid and how their nature of duties and responsibilities. If you have some friends or relatives, you may ask from them. It would be better for you to just to get an idea about the industrial exposure as well as the jobs you are available in the industry. Once you come up with the conceptual database model, then you have to come up with a logical design. Then you normally do something called normalization. I think you might have heard about the normalization. There are many different levels. With the normalization, we eliminate null values and redundancies in a database. Otherwise, just implementing the ER diagram you design would not work fine in databases. Now, the databases, you feel like several records would not make much difference. You have to think in terms of millions of records. Right? If your particular database, even one table would have millions of records. Right? Now, if you look at the customer base of a telecommunication provider, right, they normally say in the advertisement, we are having this much of clients. Right? In Sri Lanka, you can figure out how much capacity as well as how many records available in certain databases. Right? It's not only one table. Yeah, should be definitely many tables, but now you can think how it is difficult to generate monthly bill out of the records available. And when you take a call, some packages are paid for second, they charge you for second, some others are charging for minutes. So depending on the package, how complex that databases are. Therefore, actually we can't imagine how those things are calculated and properly comes to your bill without any failure. Right? So you have to think in that mindset. Then only you get to know about the importance of systematic way of implementing a database. Otherwise, now you just think of a practical situation. One of your clients would be blaming about the bill that a particular telecommunication provider has produced them. Right? So let's say it is giving inconsistent value in the account they are having of that particular under that particular telecommunication providers. So if you get hundreds, thousand complaints for a day, then how can you tackle that thing? It's very difficult. So that is the actual situation you have to face in the industry, right? So everything to work smoothly, we have to have a very planned, proper way of database implementation. Then there are many roles associated with databases. We'll be looking that as well. So once you have done these, completed those 4 parts, you can successfully implement a relational database. So I think you are familiar with ER diagrams. So I would be giving you some exercise so you can quickly take this into your notebook, then you can try to attempt this. After this slide, you have another one in the other next slide as well. So you first take this into your notebook or piece of paper, then let me know. First you take this and let me know, then I'll show you the next slide, and you can take that as well into your notes. Then after you can attempt, I'll give you some time, then we can discuss, then we can conclude this part. Okay, so with the things we discussed, you can come up with answers to this question. First quickly take this into your notebook, then I'll show you the next slide of this exercise. This is explaining you some description of a company, so you can come up with an ER diagram for this. So now you can attempt all the questions in this exercise.
Okay, sir.
Definition language.
The purpose is used to define database structure.
Yeah. So normally we refer as DDL. We have to structure the define the structure of the database, like creating schema, tables, indexes. Everything is created using DDL statements. So basically what you have experienced is DDL, right? So then there's another one called data control language, used to retrieve the saved data, and permission, access control, everything comes under DCL. So normally when we access the permissions, you can use grant and revoke commands to give access control. In databases, we have to give different access level restrictions to different parties who are involved in database systems. Other thing is data manipulation language, which is used for accessing, manipulating data. So select, insert, delete, update, like statements are to manipulate data. What you do is you write queries like select and insert queries, delete queries, update. With that, what happens is you manipulate the data in the database. Then transaction control language. With that, have you done transaction in previous semesters?
No, sir.
All right. Then again, what you do is now when you let's say you are accessing the bank's database via many different devices users can access, but then if you use the same set of commands, there can be in a sequence which we call a transaction. So it has to be also controlled and catered, otherwise you come up with deadlocks. There are many properties to be handled when we discuss about a transaction. For the moment, keep in mind there's something called transaction. What you do is actually a transaction, but internally your interaction will be into a transaction which is referred as database transaction. Right. Then, as we have already discussed some of the key concepts, there can be most probably primary key, foreign key are well known key, and we have something called super key, which can be also used to identify a raw on a well. And candidate keys are, if you check the word candidate, it also gives the meaning, the suitable set of keys which having the qualifications to become a key can be considered as candidate keys. Now, in our day-to-day life, we also call the students are candidates. So it means you have the qualifications to become a proper undergraduate in the university. In the same way, out of the candidate key, you can get one key or a set of keys to form a primary key. If you take a set of keys to uniquely identify a record, then we call it a compound key. And there can be a composition of several keys, but you may not be using it as a unique identifier. Then it can be a composite key. Then the surrogate key, so when there's no naturally available primary key, then we have to come up with something like a key created by us. For an example, we may use an ISBN to refer a book. There's nothing called ISBN a book if we have not specified that. Right? But book should definitely have an author. It's a known thing. So in the same way, it can have a title, but it may not have a key, unique key to identify. You may have many books with the same title. Therefore, we have introduced something called ISBN. ISBN can be considered as a surrogate key in database keys. Then generalization versus specialization. When you have a hierarchy of dependencies, you always get general things, you climb up the hierarchy. When you traverse up the hierarchy, you always get general things. Right? Now, let's say you have a hierarchy like vehicles, then if you traverse down the hierarchy, you get specific thing. The two, generalization and specialization, are opposed to each other. So when you have hierarchy, the topmost level is the most general level of the objects in the bottommost level. Right? Now, as I told you, if you take vehicles, there are special vehicles where you can travel on roads, seas, and sky. You can categorize like that. Then all are vehicles. Then you can further categorize the vehicles run on roads, can be buses, cars, lorries, likewise. Then you go for specific type. It is considered as specialization. You come up with more special versions. Then if you traverse upwards, you find the general version. Right? If to draw a hierarchy, then you definitely will observe that. Okay. Then if you check the roles of a DBA in brief, the DBA is one of the major roles in related to database. The database administrator is responsible of installing and configuring databases. And he has to monitor the performance of databases. Sometimes there can be replicative databases depending on different situation. For instance, you may have a disaster recovery plan where once a disaster happens, you have to recover from the disaster. And you may also have another thing called business continuity plan. Then in between, you may need to have, to implement that, you may have different database systems, separate system, but syncing to each other, and you have to always monitor and check whether the load balancing is also happening. The other thing, he has to implement the security. The proper access levels has to be implemented, and their restrictions has to be taken care of. Apart from that, one of the major duties of a DBA is to create backups, regular backups. He needs to create regular backups, otherwise they may not be able to recover if something went wrong, right? So if you just imagine if something happened for a banking database where you cannot recover, then after you cannot imagine what to do. Therefore, always we should take preventive, corrective measures. Then DBA has to troubleshoot some database related thing, and he also should do some data migration activities. These are major responsibilities for DBA. If you have some relative friends who is working as DBAs, you can ask for more clarification, and you can get the real experience they have. Okay. And this is some sample answer for the ER diagram. You can just have a look at, and which you have drawn definitely may be different from these. But anyhow, look at the cardinality ratio is also mentioned here, and more descriptive ER diagram is drawn. You can compare your one, and there can be different ways of drawing an ER diagram. So you can come up with several ER diagrams for a given scenario, but out of that you may select the best one and come up with a schema and then normalize. Now we'll briefly look at the pre-DBMS databases. Normally they are traditional file processing systems. But the problem is, as the application grows, you cannot still survive with the shared files and multitude of file structures. Therefore, we need to exchange where we need to exchange data among applications. Therefore, we have come up with the era of relational databases. When we talk about database approach rather than file processing approach, we are addressing these type of problems. We give the solution for this type of problems. The redundancy, that is the maintaining multiple copies. But you have to keep in mind, if your database is not properly designed, you can still introduce many redundancies. If your ER diagram is not properly converted to a schema and then normalized, then you cannot assure database is not having redundancy. But as a rule, we cannot avoid 100% redundancy. We can maintain only controlled redundancy. There are situations where we may need to have some redundancy. For an example, when you use foreign key, it is one of the keys in another table, right? Then that field get redundant, right? That particular field is going to be have replications of the database, but we never want to have a complete record of redundancy. Like for an example, you may have your personal data in one table called student. If you read that particular row, that row would not be available in none of the other tables in your database, even within the same table, right? The whole record. The fields can be duplicated or replicated, so may have redundant values depending on the requirement. Actually, there's a requirement for that. Right? So with the requirement, you can have several copies, the same value. Otherwise, we cannot make like a key constraints like foreign key. We cannot maintain. The other thing is regarding all the file processing systems, it is very difficult to handle the inconsistency. Therefore, we give the solution from database side to address the independent updates. And the other thing is inaccuracy. We introduce a lot more concurrent updates. Since you have not done the transaction, you may not feel the concurrent updates. If the same record is being updated by two different people, then you lose some data. Right? For the moment, yeah, let's say, I think I told you last week as well, if you write something on a notepad file and save, then you can open multiple copies of the same notepad file. Now let's assume you are writing, you are typing some new text from the copies you have opened. Right? When you try to save, let's say you have opened 3 different copies, so you lose any two copies, the data having of 2 copies. Therefore, the one you saved at last only be saved, otherwise it will get overwritten. So if you try to concurrently update, then we cannot actually assure what would happen there. Therefore, we have to avoid concurrent updates. You can always allow concurrent reads, because there's no issue with the reads only when you are updating some values. The other thing is incompatibility. That is, you may have multiple formats. So with databases, you can structure it to a unique format. Therefore, it would be very easy to be handled by the applications. The other thing is insecurity, that is lack of security. Normally we call it proliferation. It can also be handled. It's a duty of DBA as well. We discussed that with user level restrictions, and there can be many security measures can be implemented using databases. And the other thing is inauditability. It's a poor chain of responsibility. If you cannot audit what happens with the database, for an example, who deleted this record, or who inserted, or who did the changes to the database, then anyone can do some unwanted activities related database where you cannot find even what happened to the database. Therefore, these relational databases introduce different mechanisms where you can set the configuration. When something happens, it can be figured out. Also, database introduce masking. It's again a way where only the actual figures can be masked. For an example, even a system administrator should not be able to check someone's personal details. So let's say the identity card number, you can mask only the last 2 or 3 several digits can be visible, right? So the rest of the things is hidden to the user, not only the user's DBA as well. So that kind of things can be implemented using databases. And the file processing systems are inflexible. You know, it is very difficult to manage with file, but databases are very smart, and you can have multiple copies and synchronization. Lot more you can create very easily with the application. Those are advantages of database approach. So with that, we can find main characteristics of database approach. The programs are isolated through something called data abstraction. If you take one example, as I already discussed at the beginning, you may insert your ATM card to the ATM machine. You do not see any underlying mechanism, what is happening to your details of the ATM, how it is being validated, verified, how the dispenser is going the money you want, the cash withdrawal is being happened. You just insert the card, then PIN number, you select only the service you want, right? Therefore, that part is hidden. So that type of things, the underlying mechanism is hidden to the user. Then the other characteristic is multi-user transaction processing. Since you have not done transaction, but for the moment you just think the transactions can happen in sequences. So it encapsulates the sequence, and sequence of operations have to be happen automatically. When you do the transactions, I'm not sure where you find that. Anyhow, you just keep that in mind. It is another advanced thing happen related to operational databases. Then other thing is data is self-defining. So as I told you several time ago regarding the metadata, the data contained in the database is said to be self-defining. The data about the data is stored there, so you can find not only the data you stored, but data regarding your database and other related things. To do that, it uses something called database catalog. It is normally accessed by the DBMS software. So whenever the database users need information about database structure and lot more other things, as I told you previously, it can be found from the database catalog. Metadata, as I told you, it can be any related thing regarding your data in the database. It can be number of tables, it can be the disk capacity utilized, the processor, how much processor is being utilized. Such data can be considered as metadata. So as we already discussed, so DBA is responsible for authorizing access to the database, coordinating, monitoring its usage, and acquiring software and hardware resources. Whenever your hardware is not enough to run the database, when it grows, you need to come up with new hardware and software. And it is his duty to tune the DBMS for the best performance. For an example, out of the millions of records, how you select only one record within that million records within a split second. Right? Now you can imagine how your ATM PIN number is being validated within the instance you entered. Right? It does not take time to validate, and network traffic time, everything. With everything, it won't take time. So, apart from database administrator, there can be database designer. So his duty is to identify the data to be stored, right? And choosing appropriate structures to represent and store these data. When you actually, as undergraduates, you may be doing this database designers part. You get the requirements and you analyze, then you come up with a logical schema. With normalization, you identify the set of tables in the database. When you identify, you have to implement using a proper database system in order to implement your database. Now we have other set of actors like end users. End users can be naive or parametric end users. Just use some queries and updates. Others are just information for you, and casual causal end users, where they interact with on occasional or specific purpose. And sophisticated end users like deep, who are having deep knowledge of database design and DBMS facilities. And standalone users, they are actually professionals of using database. Apart from that, there can be system analysts to determine requirements of end users, and application programmers. Normally, software engineers and software developers can be part of these application programmers. They have to deal with the applications and come up with business logic as their programs. Apart from that, we have DBMS system designers and implementers, and tool developers, and operation and maintenance personnel. Right? So you just think how many staff needed to maintain a database. Right? In a company, you may encounter many positions related to database, because those duties cannot be completed by a single person, and the responsibility is also very high. Right? Now look at one example. You can just first go through the slide. Our database, you can come up with some queries to retrieve the transcript. In order to do that, you have to properly design and analyze and design the database. So when you want to do some updates, you can something like change the class of Smith into shop mode. You can create a new section of database for this semester, or you can enter a grade of A for Smith in the database section of last semester. Likewise, you can come up with many updates. This overall process involves getting the requirements and conceptual design, logical design, and physical design, that is your implementation. Now, if you look at this implementation, so you can cater for such queries like generating the transcript at the end of your course of the degree program. Right. Now we briefly look at the self-describing nature of database. Now, I told you something called database catalog. You can see an example when I was discussing about the metadata previously. I refer the term catalog. So here's an example. Now look at what type of data. This is only an example. With this example, figure out what type of data can be retrieved about the data we have stored in the database. Actually, we have not created any of these tables, right? It is automatically happening, and it maintains this data. Whenever we require such data, you can query from this. It depends on the different database management systems. The table you should refer is different, but the concept of metadata is there. If you take another example now, let's say as a application programmer, you may sometimes need to query from a table, but if you are not sure how the table is structured or organized, so you can ask the DBMS to describe the table. Fine. Then it would show you the structure of the table, so number of columns, what are the data types of each column. Likewise, it will describe the table you want. With that, you can understand how to prepare your query to retrieve or whatever the interaction you want to make with that table. One example for metadata, using metadata, what we can do is something like that. Useful information can be retrieved. Okay. With that, we conclude today's lesson. Do you have any questions up to now? We find out everybody of you can send me your attendance. You can send privately your registration number and name. Right? So you can send, and once you send, you can leave the lecture.